What if you could actually edit reality? I'm not talking about just editing a photo, but the real fabric of a scene. Changing day to night, summoning a snowstorm out of thin air, or just making objects vanish like they were never there. It sounds like something straight out of sci-fi, right? Well, for the world of self-driving cars, it's quickly becoming a critical, life-saving reality. So let's dive in and see how this incredible tech works and why it's so important. Okay, just look at this. On the left, you've got a perfectly normal, sunny day. Then, with just a simple command, the AI turns it into the scene on the right, a completely believable night scene. And what's crazy is, the buildings, the cars, they haven't moved an inch. But the entire atmosphere, the lighting, the shadows, everything is flawlessly changed. It's just, wow. And it is not just about the time of day. Here, we've got that exact same sunny street, but now it's covered in this super convincing layer of snow. Look at the reflections on the wet road, the way the snow is dusting the rooftops. This is not some simple filter. The AI actually understands the physics of how snow interacts with a city. It's like digital alchemy. So you're probably asking two things right now. How is this even possible? And maybe more importantly, why does this matter? Because this isn't just about making cool special effects. It's about solving one of the single biggest roadblocks in making self-driving cars truly, genuinely safe. And that brings us right to the heart of the problem, something you could call the simulator's dilemma. Because the magic we just saw, it isn't for show. It's designed to solve a very serious, very high-stakes challenge for the folks developing autonomous vehicles. Here's the thing. For us to trust a self-driving car, it needs to have seen almost everything. And I mean everything. We're talking billions of miles of driving data. But you can't just drive around hoping for a freak blizzard to hit in the middle of summer, or for a deer to jump out at the exact wrong moment. Trying to collect data on these rare, dangerous edge cases in the real world is just too slow, too expensive, and honestly, way too dangerous. So naturally, companies turn to simulation. But here's the dilemma. On one hand, you can create purely synthetic scenes, kind of like a super high-tech video game. They're easy to control, but they just don't have all the weird, subtle details of the real world, so engineers never fully trust them. And on the other hand, trying to edit real driving videos has always been just about impossible to do realistically. Well, until now. This is where this new technology, SceneCrafter, comes into the picture. And at its core is this brilliantly clever idea, a teacher-student learning system. So how does this actually work? Well, the process is pretty fascinating. First, you have these specialized teacher AIs that just spend all their time creating a massive library of perfect before and after edits. Think of it like a giant, flawless answer key for reality. Then, a single student model comes in and studies this entire dataset, learning all the patterns and rules until it becomes a master editor itself, ready to handle almost any request you throw at it. Okay, but how do those teacher models get so good in the first place? How do they learn to see the world and then manipulate it with such insane precision? This is where we get into the real secret sauce of SceneCrafter. All right, let's take a big scene-wide change, like the weather. A normal AI might accidentally warp the buildings or kind of shift the cars around when it adds fog. It messes with the geometric bones of the scene. SceneCrafter has this really clever trick. It basically freezes the part of the AI that understands the scene's structure, the bones, and only lets it change the skin. Things like lighting, textures, weather effects. That's how it keeps everything so perfectly consistent. But what about removing things? Now, this presents a really interesting puzzle. I mean, think about it. How can an AI possibly learn to draw an empty street if pretty much every single picture of a street it's ever seen is packed with cars? It's like trying to imagine a forest without any trees. The solution is just so elegant. It's a technique called masked training. During its training, the AI is shown a normal street, but all the cars are digitally hidden. They're masked out. The AI's only job is to realistically fill in those blank spots. By doing this millions and millions of times, it's forced to learn what the road, the sidewalk, the buildings behind the cars look like. It essentially learns the empty street by looking right through the traffic. So the theory is really impressive, right? You've got the teacher-student model, the bones versus skin trick, the masked training. It all sounds fantastic. But does it actually work any better than what's already out there? Well, let's put it to the test. Here's a head-to-head comparison. On the left, a top competing method tries to add fog to the scene. And, it gets the general vibe, but if you look closely, the details are all smudged and kind of dreamlike. Now, look at SceneCrafter's result on the right. It's sharp, the fog feels real, but the structure of the buildings and the cars stays perfectly solid. The difference in quality is, well, it's night and day. And hey, don't just take my word for it. In a study, real people were shown edits from different AIs and were asked a simple question: which one is the most realistic? The results were, well, they were a landslide. Over 85% of the time, people chose the edit made by SceneCrafter. But here it is, the ultimate test: 3D consistency. You have to remember, a self-driving car sees the world through a bunch of different cameras at once. So for simulation to actually be useful, a car in one camera's view has to line up perfectly with that same car in the next camera's view. Engineers use a specific metric to measure this, called 3D LPIPS. And all you need to know is, for this score, lower is better. And this is the knockout punch. The 3D consistency score for actual, real-life video footage is 0.186. The score for another leading AI simulator? It's way up at 0.249, which is much worse. And SceneCrafter? It clocks in at 0.187. I mean, that is basically identical to reality. Its edited scenes are just as 3D consistent as a real-life recording. That's incredible. So, what's the big takeaway here? What does all of this mean as we look towards a future with more and more autonomous cars on our roads? All right, so let's wrap this up. What have we learned? We've got SceneCrafter, this super versatile AI that can realistically edit real-world driving scenes. It uses that clever teacher-student system to basically train itself. Its big secret is that it knows how to preserve a scene's geometry, its bones, while changing things like the weather or adding and removing objects. And the most important part? It creates simulations with a level of realism and 3D consistency that is, for all practical purposes, indistinguishable from real life. This technology pretty much solves the data problem for teaching cars how to see. We can now create a nearly infinite number of rare and dangerous scenarios to train and test these cars in total safety. Which, it leaves us with one last big question. If we can teach an AI to see the world perfectly by flawlessly editing reality, what's the next great challenge we have to solve on the road to truly safe self-driving cars?